The alignment is fairly close at this point, so we can move to the dial indicator for the final adjustments. The dial indicator will allow us to precisely measure the relative movement between the coupling hubs as they rotate. Assemble the dial indicator as shown and clamp it onto the motor shaft. Position the indicator contact point on the hub mounted to the pump shaft. Preload the spring-loaded indicator to approximately 1/2 of its total travel distance of 200 thousandths of an inch. The initial position should be with the plunger centered in its travel range. This way it can measure movement in either direction. Zero the dial at the 12 o'clock position. Ideally, we want to take measurements at 0 degrees or 12 o'clock, 90 degrees or 3 o'clock, 180 degrees or 6 o'clock, and 270 degrees or 9 o'clock. In this case, like many real-world installations, the indicator cannot be moved to the 6 o'clock position. From our class discussion, we know that only 3 measurement points are needed if we use the validity rule to read true position. Rotate the coupling until the indicator is at the 3 o'clock position, then zero the reading by rotating the bezel on the indicator. Now rotate the coupling 180 degrees so the indicator is at the 9 o'clock position, and note the reading. The indicator is reading approximately 6 thousandths. This is the TIR total indicator reading. Since the indicator captures the misalignment on both sides of the shaft, the actual offset is 1/2 of this reading. Adjust the bezel to read 1/2 of the TIR reading, 3 thousandths. The indicator will now read true position, or actual offset, at any shaft position. If we roll the indicator back to the 3 o'clock position, it now reads the true position of -3 thousandths of an inch instead of 0. Moving back to the 12 o'clock position, we see a reading of +4 thousandths of an inch. This means our motor is still 4 thousandths of an inch too low. A negative reading here would indicate the motor was too high, and we would need to reduce the shim thickness. Loosen the mounting bolts to add a 4 thousandths thick shim at all 4 locations. Retighten the mounting bolts using the same starting point in sequence. Repeat the process. Rotate to the 3 o'clock position and zero the bezel. Rotate to the 9 o'clock position and adjust the bezel to read 1/2 of the TIR, or total indicator reading. In this case, TIR equals -12 thousandths of an inch, so we adjust to -6 thousandths of an inch. Rotate back to the 3 o'clock position and we read +6 thousandths of an inch as expected. The 12 o'clock position reads 0, confirming our vertical alignment is correct. No further adjustment to the shims are needed. The last step is to correct the horizontal misalignment. To do this, slightly loosen the mounting bolts and use the dead blow hammer to tap the motor into alignment. Retighten the mounting bolts in the correct order. Recheck all three positions. All readings are within 1,000th. The hands-on requirement for class is less than 5,000ths of an inch. Thanks for watching. Visit industrialmaintenancetraining.com for more resources and connect with our customer service team anytime at sales@mstservices.net. We look forward to helping you succeed.